Good afternoon, class. Today we're going to be doing a screencast on probability. So I did not see you Friday, unfortunately not seeing you today, but we will touch base again tomorrow on Tuesday. Uh, so hope you had a good weekend. Let's dive right into Monday. So your screencast, like I said, is going to be on probability. Then the sub is going to give you a review worksheet, which will be handed in, and then from there you're going to have no homework, but that's because you have the pre-test makeups that are due tomorrow. And those are due at the beginning of class, so please make sure those are done. And just a reminder, you have your Unit 1 test on Thursday. So you need to have that pink sheet out, just a pencil, and we're going to take some notes on probability. So probability, the definition for probability is probability equals the number of winnings or your desired outcomes, and that's going to be over our number of possibilities. And if that sounds confusing right now, we're going to do some examples of what that means, how that relates to geometry. So the first one, we have this triangle. So what we're going to do first is we're going to just list all the different triangles. If I can get my cursor over there. Alright, so our different triangles are, we have triangle AED. Here's one, that's AED. And then you have EDB. And then you have triangle BDC. And then you have triangle AEC. And then last one, we have triangle EDC. And you're probably wondering why we wanted to list all the triangles. Well, what we want to know is we want to know how many triangles have the side EC. So how many triangles have the side EC? So looking at the triangles that we listed below, triangle AED does not have EC. Triangle EBD does not have EC. BDC, BDC, again, not EC. AEC, yep, that one has EC. And EDC also has side AC. So we have 2 out of the 5. So our probability is just 2/5. Or 0.4. Or you could say also 40%. So here our number of winnings is those 2 EC sides. The number of possibility is our 5 triangles. Again, the nice thing about a video is if you ever get lost or if you ever want to rewind, you can always rewind to get another explanation. So the next thing we're going to look at using this same diagram is we're going to look at points. So if 2 points we're in all caps, that's why. So if 2 points are chosen at random, what is the probability that they will name a segment in the diagram? So if we just choose 2 points at random, any of these points, what's the probability that we get a segment that is in this diagram? So first off, let's just start doing our possible outcomes. Let's name all of our different point combinations. So we have AC, AE, AD, AB, DE, DB, DC, EB, EC, and BC. Those are all the different combinations we could have. So let's look at them and see which ones are on our diagram. So is AC on our diagram? Yes, right here. What about AE? Yes, that's right there. Let's put a Y for yes. AD? Yep, that one's on there. AB. So there's no segment AB. DE, yes. DB, yes. And if you keep going, you get all the other ones being yes as well. So we have 10 total. So again, remember what probability is? It's the number of winnings or desired outcomes over a number of possibilities. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes, and 9 of them are correct. So it's 9 out of 10. Or again, you could say 0.9 or 90%. So that is the answer for that one. Moving on to the segment. So in this case, we're going to look at what is the probability that a point chosen at random on AB is within 5 units of 13. So let me type that down so you can see what we're asking. So we're looking at the probability that a point is chosen at random on the segment AB is within 5 units of 13. So we have this segment that starts at 5 and goes to 20. So the length of this whole thing is going to be 15. So from here all the way to here, that's 15. Now what we want to do is we want to mark 13. So 13 is probably somewhere around right here. So there's 13 on our number line or on our segment. And then we want to know if we choose some random point, what's the probability it's going to be only 5 units away. So 5 units this way is going to be 8. And 5 units this way is 18. So again, how far is this? Again, we want to look at number of winnings versus number of possibilities. So in this case, a win would be something that is within 5. So within 5, there's 10 points that are within 5. So there's 10 points within 5 units of 13. And that can all be over our total, well, 5 to 20, like we said, 15 total points. So our answer is simply just 10 over 15, which we can simplify to, well, that equals 2 over 3, or 66.7% if you want to round. Again, if I'm going too fast, go ahead, pause the video, rewind, and make sure you understand. So the last two are the dart game, and I move these so you can see these a little better. Okay, so what we want to think about here is if we threw a dart at this square, what is the possibility it's going to land in this little square? So in this case, we're talking about area. So in this type of problem, you have to find the area. Well, what's 5 of the big square? That's the bottom part. That's our number of possibilities, or that's the area that we could hit. That's the possible area we could hit. And we want to know what's the chance we hit in this little blue square. So the total area is just, so the total area is just 5 times 17, or length times width. So 5, not 17, excuse me, 5 times 7. So 5 times 7 is 35. And now the area of this little blue square is 9. So our probability is just 9 over 35. That's what the probability equals, 9 over 35. Because this right here is our winnings or our desired outcomes, and the total outcome or total area is 35. Now we could simplify that if you wanted to. You could put it as a decimal or percent, but I'm just going to leave it as a fraction. And now the last one is we have this angle, and we want to see if we threw the dart, what's the possibility that we land in this DBC. So if I threw the dart at this angle, what would be the possibility to land in DBC, that smaller angle? So again, our big part, or the possible outcomes, is landing anywhere in between A, B. So that's going to be 48 plus 32 degrees. And that equals 80. So that's our possible outcomes. And then we want to know, well, what's our desired outcomes? Well, that's just DBC, or 32 degrees. So our probability equals 32 over 80. Or we can simplify that down to 2/5. Alright, so I hope you enjoyed that little intro to probability for geometry. So I know you've done probability in the past. Hopefully this desired outcomes over possibilities doesn't confuse you that much. It's just now we're just applying it to geometry and using points and segments, using line segments, and then using area or angles. So just a quick reminder, you do have a worksheet now that's going to be handed in. It doesn't have that much probability on it. It's more of a review worksheet because you do have your unit test coming up. We will review everything you learned on Friday and today on Tuesday, and then we'll do a full unit review on Wednesday before your tests. Please come see me if you have questions about the pre-test makeups that are due tomorrow. Remember, your write-up needs to be typed and handed in at the beginning of class with all your problems. You don't have to type those up. You can just handwrite those. Shoot me an email if you have any questions. Enjoy the rest of your day, and I'll see you on Tuesday.